Welcome to the third and final part of the answer nugget for Test 2 Mock for PSY1017. This part will deal with questions 9 to 13. I'll move fairly quickly through these, as much of the explanation given in part 2 on questions 4 to 8 applies here as well. These questions deal with Professor Barrett's concern over a relationship between gaming time and academic grades. In the second nugget, it was stressed how, for this test at least, when you spot that you're looking at a relationship, you should perform a correlation. But let's start with question 9. This asks you to reframe Professor Barrett's research question in terms of the two hypotheses that are at the heart of a null hypothesis significance test: the null hypothesis and the alternative hypothesis. You should recall from the second part of this nugget that these hypotheses are essentially two broad explanations for what's going on with the relevant populations and for what we see with our samples. In the previous analysis, we were dealing with differences between means. Here, as just noted, we are dealing with a relationship between variables, and hence a correlation. The first explanation, the null hypothesis, is that there is actually no relationship or correlation between the scores of the two populations, and that any relationship or correlation we see between our samples is just due to sampling error. The other explanation, the alternative hypothesis, is that there is a relationship or correlation between the scores of the two populations, and that's why we see a relationship or correlation in our sample. Remember, this analysis and these two particular hypotheses are all about a relationship. Don't talk about differences between means here. That wouldn't make sense. On to question 10. This asks you to generate a suitable graph, giving it a title. When you're looking at a relationship, a correlation, the most suitable type of graph is a scatter plot. To produce one of these, go to Graphs, Chart Builder. Choose Scatter/Dot from the list of chart types at the bottom left, and then choose Simple Scatter from the varieties available. At the top, drag the hours spent gaming variable onto the y-axis and the mean academic grade variable onto the x-axis. Or you could do it the other way around. It doesn't really matter. Click OK to generate your graph, which should look like this. Give the graph its title by double-clicking on it, selecting Title from the Options menu, and then typing something like Scatterplot of hours spent gaming and mean academic grades. Moving on to question 11. For this question, you need to conduct a suitable null hypothesis significance test. Note that you don't copy and paste anything here, you just type the relevant values in. No marks will be awarded for copied and pasted output. As mentioned many times now, the statistical procedure you should conduct here is a correlation. To perform this, go to Analyze, Correlate, Bivariate. Move both the gaming and grades variables over to the box on the right. Check you're asking for a Pearson's correlation, and then decide whether you want your null hypothesis significance test to be one-tailed or two-tailed. There isn't any predicted direction in the question or the alternative hypothesis. Barrett is just looking for a relationship, and our alternative hypothesis is simply that there is a relationship. A two-tailed test is therefore most correct. Click OK, and the resulting table should look like this. Now, our test statistic is the Pearson's product moment correlation coefficient, or R, which we can see is minus 0.072. The other Pearson's correlation is the same, as it's for the same two variables just entered in the opposite order, which makes no difference. The degrees of freedom are a little trickier. They aren't directly stated in the table. However, you are given the n size, the number of pairs of scores, which is 100. For a correlation, the degrees of freedom are n minus 2. So in this case, 98. Why n-2 and not n-1? Well, a rough answer is that you have two variables in a correlation, and so it's -1 for one of them and another -1 for the other. Finally, for this question, you need to give the obtained probability, the p-value or sig. You can read this off as 0.474. Question 12. You need to use the downloaded syntax file to generate a 95% confidence interval for the value of r you computed for question 11. The key thing here is that you need to create a fresh, empty data file for this. To prevent confusion, it's probably best to save both your data file and your output file, and then start up SPSS again with a blank data file. In this new data file, you need just two variables, n and r. Switch to the variable view and name the first two variables n and then r. Our value of r was given to 3 decimal places, -0.072. So change the number of decimal places for your r variable to 3 as well. Switch back to data view and enter in the values for n and r. Remember, it's n, not degrees of freedom. Then, open the downloaded syntax file, which should look like this, and select All from the Run menu. This table should appear in your output file. You can see the clearly labelled lower and upper values of the confidence interval, -0.265 and 0.126, rounding to 3 decimal places. This just leaves question 13. Here, you interpret your answers to the previous two questions. As for question 8 for the other analysis in the second part of this nugget, there are two aspects to this: the correlation and null hypothesis significance test, and the confidence interval. I'll talk about the correlation first. The first thing to note is the value of the correlation coefficient, -0.072. It is very small and rather close to zero, i.e. no correlation. The coefficient is negative, but when it is this close to zero, you can't make too much of that. Now we can interpret the null hypothesis significance test by considering the p-value or sig. As mentioned in the previous nugget, this is a probability that assumes that the null hypothesis is true, i.e. that the population correlation is equal to 0. This is the probability, assuming H0 to be true, of getting our data or more extreme. How rare or how common would our data be if the null hypothesis was true? If the population correlation is 0, what proportion of the time would you get a sample correlation such as we did? If it would be unusual to get our data were the null hypothesis to be true, then we could reject H0 as our explanation for our data. As usual, we evaluate unusual against a criterion of 5%. Is our p-value less than 5% or 0.05 in decimals? Our p is 0.474 or 47.4%, so clearly a long way from being less than 5%. We cannot therefore reject our null hypothesis, but remember, this is not the same as accepting the null hypothesis. All we can say is that we have failed to reject our null. Turning now to the confidence interval. Remember, this gives us a range of plausible values for the population correlation. The interval runs from -0.265 up to 0.126. First of all, we can say that the interval does contain 0. This is consistent with our decision not to reject the null hypothesis that the population correlation is 0. Secondly, the interval is almost 0.4 wide. That's a pretty wide interval for a correlation coefficient. We can conclude, therefore, that our sample correlation coefficient was close to 0, but with a wide 95% confidence interval of minus 0.264 to 0.126. We failed to reject H0 as our p-value was greater than 5%.